Okay, thank you very much and welcome to this spatial epidemiology class. You have learned your basic epidemiology and you learned about advanced epidemiology. So, in advanced epidemiology, especially, we have seen different subspecialties of epidemiology. Among the subspecialties of epidemiology, we have seen clinical epidemiology, infectious disease epidemiology, cancer epidemiology, molecular epidemiology, genetic epidemiology, nutritional epidemiology, spatial epidemiology, and a number of varieties of subspecialties are there in epidemiology. So out of these subspecialties of epidemiology, spatial epidemiology is one of the component. So in this class, we are going to see an introduction to what does spatial epidemiology is to mean. So okay. So we are going to cover some introduction contents in spatial epidemiology. So, as the name indicates, this is an introduction to spatial epidemiology. So we may not go into in details of what spatial epidemiology is, but just introductional contents and ideas will be covered in this session. So the learning outcomes or objectives in this session will be just the definition of spatial epidemiology. So we are going to see what does this spatial epidemiology is mean by and what makes it different from general epidemiology. So what does it mean? We need to define and we need to understand well what we mean by spatial epidemiology and really how it differs from the classical epidemiologic definition. And then we'll proceed to see the components of spatial epidemiology. What are the components under spatial epidemiology and what are really the importance of these spatial epidemiology components and the objectives of and activities that would be done in different components of spatial epidemiology will be dealt, and we need to describe the historical background of spatial epidemiology. Anything cannot happen without anything cannot happen suddenly. So everything will happen because of a reason, and for that reason there is some historical background. So we will see what historical backgrounds were there in the spatial epidemiology, and then we'll try to explain the role geographical location that plays. The role of this geographical location in terms of health and disease in a community. Why you are concerned about the location or the geography in which the community is living in relation to with the health of the community. So what's the role of knowing the geography in terms of the field of medical science? So I will try to explain the role of geography on the health and health-related events of a community. And then we'll just proceed to describe the application of spatial data in the epidemiology and public health. How this spatial data or geographical data will be applicable to the epidemiology and the public health. That means how this geographical data will be useful or applicable for the health of the public, for the health of the community. How it could be applicable and in what way. And then we'll discuss the concepts and the frameworks of spatial analysis. What is the spatial analysis is to mean and what frameworks are there, and we'll see some introduction for spatial analysis. So what does that mean and how this spatial analysis will be done will be covered in this introduction to spatial epidemiology course. So, the definition for spatial epidemiology, the components, the historical perspectives, the applications, the concepts and frameworks of this spatial epidemiology will be the concern of this spatial epidemiology course. So now, let's come to the definition of spatial epidemiology now. Let's come to the definition of spatial epidemiology. What does it mean? What does spatial epidemiology is to mean? And before defining this spatial epidemiology, let's just revise the definitions that you have learned in your basic and advanced epidemiology course. You know, the term epidemiology by itself should be defined first, and then based on the definition of this epidemiology, the spatial epidemiology will just proceed. You know, because knowing the definition of epidemiology will be an important input or clue for a definition of spatial epidemiology, because spatial epidemiology and epidemiology by itself are interconnected to each other. You know, they are not dichotomous. So the definition of epidemiology will be an input or just a clue or an important idea or understanding in order to understand the definition of spatial epidemiology. So as you know from your basic and advanced epidemiology course, epidemiology is defined in such a way, you know. It is the study of the frequency, that means the magnitude of a certain disease, or maybe the prevalence, you can say. Frequency just generally encloses the incidence and the prevalence of a certain disease. So epidemiology is the study of the magnitude of a certain health condition, that is generally the frequency of that disease. And in addition to knowing the magnitude of the disease, it is also the study of the distribution of a disease, especially the distribution of the disease by time, place, and person. Three most important components in the study of the distribution of disease, you know. So knowing the magnitude or the frequency of the disease, one thing, and then again knowing or studying the distribution of the disease. The distribution of the disease in terms of time, in terms of person, in terms of place. Three most important components are there in the study of the distribution of a disease, you know. But as you have learned in your basic and advanced epidemiology and biostatistics, and any if you read any textbook and research works, much emphasis has been given for the study of the distribution of disease in terms of time and person. And less emphasis has been given to study the distribution of disease by place, that is the geography. So spatial epidemiology is one of the components of the study of the distribution of disease. That is the study of the distribution of disease by place. The place refers to the geography, which is an initial point, or which is one of the components of epidemiology, that is a spatial epidemiology. So, you know, the study of the distribution of disease by time, place, and person. When we are saying this is, we are studying a health condition or a magnitude of a certain disease in a certain population. That is the person it refers to. And then we are trying to investigate the prevalence or the frequency of a certain health condition across time, over a period of time maybe, or maybe at a specific point in time, that it is referring to the time when that the disease occurs. And then if we try to study the occurrence of a certain health condition in relation to the place where the disease occurs, it is referring to the spatial epidemiology, you know. It is referring to the spatial epidemiology. So spatial epidemiology is one of the components of in the definition of epidemiology, which says epidemiology is the study of the distribution of a disease by time, person, and place. So knowing the distribution of a disease according to the place where the disease occurs is one wing of epidemiology, which is said to be the spatial epidemiology. So spatial epidemiology originates from the definition of the general epidemiology itself, you know. So, generally, when I summarize the definition of epidemiology, it is the study of the frequency, the distribution, and then after, the most important and the conclusive idea, which could be used for any conclusion and recommendation, and based on that for any intervention, knowing the causative agents or the determinants of disease. That is most important wing or objective of epidemiology, which could tell us the causative agents or the determinants or maybe associated factors or the risk factors for a certain health condition. Because knowing the causative agents or the determinants will enable us to give a recommendation, and based upon that recommendation and based upon that evidence, an intervention would be taken, you know. The intervention could be just a clinical treatment or maybe public health intervention. An intervention which could be taken place at the population level, or an intervention which could be taken at the individual level in the clinical setup, you know. So in the definition of epidemiology, this is very fundamental. Just to understand what does spatial epidemiology is to mean and from where this spatial epidemiology originates. So spatial epidemiology by itself originates from the definition of epidemiology. Because epidemiology is the study of the frequency of a disease, the distribution of the disease by time, place, and person, and the distribution of the disease by place is one wing, and which is spatial epidemiology, you know, the concern of spatial epidemiology. And then knowing the determinants of the disease. You know, in spatial epidemiology, not only in epidemiology, in spatial epidemiology, it is also possible to know the distribution of the disease according to the place or the geographical location, and plus the causative agents, the determinants that are attached to that geographical location, which brought the disease to occur there, you know. So it's possible in spatial epidemiology also to know the determinants, not only in the classical epidemiology definition. So, as I have said, it is as it is written here there in the PowerPoint. Generally, epidemiology is defined as it is a study of the frequency, the distribution, and the determinants of disease and other health-related events, not only disease specific. It is not specific to only disease, you know. Health and health-related events will be studied, you know, in terms of their frequency, distribution, and the determinants. And the study will be conducted in a specified population. We cannot do this study in a general population, you know, at the community, to the total population. Rather, we will take a sample of the population, which could be the representative of the total population. So these specific populations will be the samples which will be taken from the total population. And then finally, after this trial, you know, and after this investigation of a disease in terms of the frequencies, the distribution, and the determinants among a specific group of the population, finally, the result will be applicable to the community in order to promote the health of the community and for the prevention and the control of health problems, you know. So the purpose of studying the frequency, the distribution, and the determinants of disease is finally in order to apply that result for the promotion of for the community, or for the promotion of the health of the community, and to the prevention and the control of any health-related problems, you know. So this is the definition really that you have learned in your basic and advanced epidemiology, you know. Okay, therefore, based upon the definition of epidemiology, now let's proceed to, okay, and actually, before proceeding to the spatial epidemiology, here is also another additional slide which talks about epidemiology. So, as I have said before, epidemiology is concerned with the measures of disease occurrence. The measures of disease occurrence in terms of frequencies that could be explained in terms of the incidence of the disease or the prevalence of the disease, and knowing the risk factors for that occurrence of the disease. Okay, and after knowing the occurrence of the disease in terms of incidence and prevalence, and after knowing the risk factor, and actually in order to know the risk factors, there should be an additional activity which could be done, that is the measure of association. The measure of association between the risk factors, the suspected risk factors with the health condition, you know, by just either calculating the relative risks, the odds ratio, incidence rate ratio, or maybe hazard ratio, whatever. All these measures of association will be calculated in order to determine whether there is an association or a relation, or at least maybe a clue for cause and effect relationship between a certain factor, a risk factor, with a certain disease. That is the concern of epidemiology that you have learned. And even epidemiology is also concerned with the measures of the impact and the implication or the importance of a certain health condition. Or it tries to measure the importance and the implication of excess risk factors, you know, in terms of maybe attributable risk percentage, population attributable risk, whatever. All these calculations will be made, at least in order to measure the impact of a certain risk factor on a certain population. So generally, in this definition, in the definition of this classical epidemiology, what is the concern is specifically to measure the occurrence of the disease and to know the risk factors of a certain health condition, and to estimate the implication or the impact of a certain risk factor in terms of its attributable risk, population attributable risk, and other measures of impact, you know. In this definition, there is no objective or concern attached to the geographical location. In the classical definition of epidemiology, you know, and actually in the classical definition of epidemiology, it is known that the distribution of the disease is studied by time, place, and person. But as I have said before, much emphasis has been given for the study of the distribution of a health condition by place and time, by person and time. And less emphasis has been given for the study of the distribution of the disease by place or geographical location. So now, so what does the spatial epidemiology is to mean? What does it mean, spatial epidemiology? If we define the classical epidemiology in such a way, as we have seen before, what will be the definition of spatial epidemiology and how it differs from the definition of the classical epidemiology, and what is the relation between this spatial epidemiology definition and that of the classical epidemiology? So, spatial epidemiology is defined in such a way, you know, it is the description and the analysis of geographic variations in disease. I said it before, spatial epidemiology is among one of the components of the study of the disease by its distribution by time, place, and person. So the study of the distribution of disease by place is the concern of spatial epidemiology. So spatial epidemiology is defined that it is the description and analysis of geographic variations of a disease. You see, the occurrence of a disease, knowing the prevalence or the incidence of a disease is one component and is very important. But that is not all, you know. That is not the end of our effort. Rather, in addition to knowing the incidence or the prevalence of that health condition, we need to know the place where the disease occurs, and we need to know the variation of that disease. That means the variation of the prevalence or the magnitude of that disease condition among different geographical areas, and why it differs among geographical locations. You see, something happens without nothing, you know. Rather, something will happen because of a reason. So what is the reason for the variation of a certain health condition across different geographical locations? So that reasons might be environmental factors, personal behavior factors, the nutritional factors, demographic factors. A number of factors will be there in different geographical locations, which could make the variation of the disease in different geographical location, you know. Therefore, the concern or the objective of this spatial epidemiology is in order to describe and analyze the geographic variation of a certain disease condition with respect to the demographic, the environmental, the behavioral, the socioeconomic, the genetic, and infectious risk factors. You know, disease varies from place to place. So, while diseases occur in different ways from different places, there is a variation in the prevalence or incidence of disease in different geographical locations. Okay, so the concern of spatial epidemiology is in order to describe this geographical variation of disease, one, and the second one is what is the reason for the variation of this disease among different geographical locations. What are the factors which could contribute for the variation of the disease in different geographical locations? That is the concern or the objective or the definition of spatial epidemiology. So, you know, therefore, spatial epidemiology is investigating the geographical variations of a certain health condition and investigating the factors that contribute for the variation of that disease in different geographical location. So spatial epidemiology is investigation of a disease attached with the geographical location and exploring the factors that brought the variation of disease in those geographical locations. This is a definition of spatial epidemiology, you know. So we focus on small area analysis. If you remember in the definition of epidemiology, the classical epidemiology, it is the study of the frequency, the distribution, and the determinants of disease among whom? Among a specific population, among representative samples of the population, you know. Analogous to that, in spatial epidemiology, our focus will be on a small area analysis. So we may not analyze the data generally in every corner of the world. So we should focus on a small area analysis or in a specific geographical location. Encompassing disease mapping in that specific location, you know. So we focus on a small area analysis and which includes a disease mapping for that geographical location where the disease occurs. The disease mapping will indicate us where the disease occurs, you know. The place where the disease happens could be identified by using the mapping, you know, disease mapping. Okay, plus geographic correlation studies. The correlation will tell us whether there is any relation or association between the disease that occurs in that geographical area and the risk factors that is suspected to that geographical location. So to know whether there is any relation or association between the risk factor and the disease that happens in that specific geographical area, we need to do a geographic correlation study. A correlation study. And then, again, for that specific geographical area, we will do disease a cluster analysis. A cluster analysis in order to identify disease clustering. To identify whether there is clustering of cases or not, aggregation of cases, clustering of cases, and plus in which geographical areas are there low clusters and high clusters will be identified by the study of this spatial epidemiology, you know. And I think someone is nagging me to join the meeting. Okay, so this is the definition and the focus of spatial epidemiology. So spatial epidemiology is also concerned with investigating how places or geographical locations are related to health. It investigates, or maybe investigating how these geographical locations or places are related to health will require learning to characterize the place, the geographical location. So, in order to investigate the relation between the health condition with that geographical location, we need to learn how to characterize that geographical location. And as well as we need to learn again to characterize the biology and the behavior of human being, So we are going to relate two agents, the environment and the host, the human being. If you remember the triangle, the epidemiologic triangle in the infectious disease epidemiology. So the environment, the host, and the agent, So the agent is the risk factor which lives in the environment. And the environment is, a favorable condition for the agent and also for the host. So the environment is the place where the agent and the host will join, or will get a contact with each other. So we need to study what are the factors there in the geographical location. We need to characterize the geography, and we need to characterize the human character in order to know the relation between the two. The association or the relation of a certain health condition which occurs among the human population with that of the geography. We need to characterize the geographical location, and we need to know the human behavior, including the biology of a human. So that is a concern of spatial epidemiology. So, and thanks to the technology, advances in geographic information system, we'll see what GIS mean. We'll have a practical session for that. After theoretical sessions, we'll proceed to that geographic information system. What does it mean? And then we'll proceed to even to see ArcGIS and ArcGIS Pro, So, advancements in geographic information system, statistical methodology advancements, and availability of high resolution imaging techniques. Geographically referenced health and environmental quality data. You see, geographically referenced health data, geographically referenced environmental data. When you say geographically referenced, it means that the location of the data where it is collected is also included. The data which is collected will be geographically referenced, mean the location for that specific data will be identified by its specific latitude and longitude. That is the geographically referenced data. Unless and otherwise the data is geographically referenced, that could not be a spatial data, So in order to be a spatial data, the data should be a geographically referenced. That means the location for that specific data should include the longitude and the latitude measurements for that specific data. So these advancements created unprecedented new opportunity to investigate environmental factors and other factors in explaining local geographic variations in the disease occurrence, So these advancements have created an opportunity to investigate both environmental and non-environmental factors related with the geographic variation of a certain disease. why a disease varies from different geographical locations could be investigated by the use of these advancements in geographic information system, advancement in statistical methodology, advancement of in high resolution geographically referenced health data. Because of this advancements, we can investigate the association of different factors, including environmental and non-environmental factors, with the variation of that specific health condition in geographical location, you know. So that is the idea. Okay, so now let's proceed. So spatial epidemiology, generally, it studies the geographical or spatial distribution of health outcomes. It studies the geographical or spatial distribution of health outcomes. I said it before. Spatial epidemiology is one of the components in the definition of classical epidemiology, which says it is the study of the distribution of disease by time, place, and person. So the study of the distribution of a disease by its geographical location or spatial distribution is said to be a spatial epidemiology. It is a spatial epidemiology. And that is why I said the definition of spatial epidemiology originates from the definition of classical epidemiology. So geographic variations of a disease, you see, our purpose, our objective is to know the variation of a disease from place to place. So the geographic variation of a disease is the concern of spatial epidemiology. And the factors which are associated with the geographic variation of a disease is the concern of spatial epidemiology. So geographic variations in disease with respect to different factors. The geographic variation of a disease might be because of demographic factors in that geographical location. The birth rate, the death rate, the different morbidity conditions, whatever. The higher the fertility rate, the higher the incidence of a certain health condition, whatever. So demographic factors related with the migration, out-migration, in-migration, the birth rate, that is the fertility rate, whatever. Mortality rate. So all demographic factors could be attached with the variation of that disease with that geographic location, or different environmental factors, water pollution, air pollution, a number of hazardous chemicals associated with in different industries, in different geographical or environmental locations. So all these risk factors could be explored for why the disease occurs in different magnitude or prevalence among different geographical locations. Behavioral factors. People in different geographical locations have different behavior, you know. Maybe people in the eastern part of Ethiopia, in our country, or maybe in the southern part of a certain country, may have a different habit than people living in the northern part of a certain country, or in the eastern or in the western part of a certain country, you know, in terms of behavior, in terms of nutrition, you see, behavior in terms of physical activity, behavior in terms of substance use and abuse, behavior in terms of social and environmental, social cultures, you know, societal cultures, marital relationship, the bondage or the societal bondage between different individuals among different locations. You see, so the behaviors are varying among different geographical locations. So the variation or the difference in behavior in different geographical locations could contribute for the variation of a certain health condition among different geographical locations, you know. Okay, other factors specific to socio-economic status. You see, Socioeconomic status of a certain community, a community could not be the same in every corner of the world or in every corner of a specific country. So people will vary in terms of their socioeconomic status. So in some geographical location, most of the community might be in the high class of socioeconomic status, but in some other geographical locations, people of the community might be at the lower socioeconomic class, and in some other geographical location, the community might be at the middle socioeconomic class. So being at the lower, the middle, and the higher socioeconomic status class could make individuals to have a different disease status, you know. So that variation in terms of socioeconomic status will contribute for the variation of a disease in different geographical location. So that is the concern of this spatial epidemiology, no? Genetic factors. We have seen in advanced epidemiology that genetically, whether a factor is genetically acquired or environmental factor could be studied by the different ecological study designs. So that's the migrant individuals from other who migrated from their origin of country to another country will be compared to the disease rates in those individuals who are living in their origin of country, and then that factor will be identified whether that disease is a genetic factor or an environmental factor. So genetic factors will be also contributing for the variation of a disease among different geographical locations. So this is and even different infectious risk factors. Infectious factors, you know, not only disease, but there are different infectious risk factors. Viral, bacterial, virological, fungal, protozoal, a number of infectious risk factors could be attached to the environment where the community is living, you know. So that variation in the distribution of the disease among different geographical locations could be attributed to the infectious agents that are attached to the geographical location where the community is living. And also, spatial epidemiology is the design and analysis of, it is not only knowing the variation of a disease in terms of geography, and it is not only a study of the risk factors attached with the variation of the disease in a different geographical location, but it is also the design and analysis of the distribution of that specific disease, the determinants of that or the factors for that specific disease, and outcomes of all aspects of health and well-being across the continuum from the prevention to the treatment. It encompasses to the level of the holistic prevention and treatment of the health status of the community, you know. So it is not only specific to knowing the variation and the risk factors. It is it goes beyond that. It includes both the prevention and the control or the treatment of that health condition in all aspects of the health of the community. So that is spatial epidemiology, you know. So spatial epidemiology involves spatial data. In spatial epidemiology, it is a must to have a spatial data. A spatial data is a data which have, for example, mortality is data, morbidity, the number of diseases, the number of morbidities. It is a data for epidemiology, but it cannot be a spatial data. Unless and otherwise, the place where the number of diseases were recorded have a longitudinal and latitude referencing location, you know. So the latitude and the longitude location of that specific record should be included to say that the data is a spatial data. So spatial epidemiology involves the spatial data or spatially derived information. That is, about the study subjects, where the study subjects were involved in the data collection, should have a spatial data or a geographic georeferencing data, you know. So it is just to mean that the latitude and the longitude location of the study subject should be included. Or maybe the health facility or sources of exposure. So all these types of data, you see, whether it is health facility, the study subject, or the sources for any exposure should have a spatially referenced location for that specific study subject, you know. So that is why spatial epidemiology is concerned with the study of disease variation among different geographical locations. It is said to be a spatial data. Spatial data. So rapidly advancing fields pushing our ability to measure, to monitor, and map health conditions. You know, the advancements of different technologies, including the statistical methodology, the geographic information system, the high resolution imaging systems, all these things have enabled us to measure, to monitor, and map health conditions at increasingly finer spatio-temporal scales. The spatio-temporal refers to the spatial location, the geographical location, and the time when that measurement was taken. So both the time and the spatial or the geographical location of that health condition could be mapped by using this technology or geographic information system. And as I have said before, advancements in the geographic information system statistical methodology, availability of high resolution imaging methods, geographically referenced health data or environmental quality data enabled us to measure and monitor and even to map the health condition at an increasingly finer spatio-temporal scales, you know. So, as you know, in the epidemiology, in the classical the epidemiology definition, person, place, and time are concerned with the distribution of the disease by time, place, and person, you know. These three elements, these are the basic elements of outbreak investigation and the study of epidemiology, you know. The distribution of disease by time, place, and person. And however, historically, the focus in epidemiologic research has been more on person and time, and little attention has been given for the implication of place or space. Even though disease mapping has been done for over 100 years ago, starting from the era of John Snow. Even though diseases were mapped by using mapping techniques, little attention or little emphasis has been given for the implication of geographical locations for the variation of a disease in the community, you know. So the development of geographic information system over the last 20 years has provided a more powerful and rapid ability to examine spatial patterns and processes, you know, to examine the spatial patterns of a certain disease, the pattern of a certain specific health condition across different geographical locations, the clustering, aggregation, or disaggregation of cases or diseases could be examined by using this geographic information system. And we'll see in detail what does geographic information system mean and how to use it. Therefore, in turn, this has fostered the discussion of such policy relevant issues, you know, as like health service and planning, as well as the use of GIS or geographic information system for epidemiological investigation and disease surveillance, you see. So the advancement of this geographic information system has fostered or give an opportunity to just focus on epidemiological investigation based on the GIS system and disease surveillance, you know. Epidemiologists understand that disease processes have a historical component. A historical component actually refers to the time component, and that is why it is included in the definition of the distribution of the disease by time, place, and person. So researchers or epidemiologists understood that disease process have a time component, and formal methods of time series and hazard analysis are well developed to study them. With regard to the distribution of the disease, it is already well investigated and have been given more emphasis to study in terms of either time series analysis or maybe survival analysis, which could be applied by the hazard ratio. So the time component of the distribution of a disease has been given more emphasis by just different statistical analysis methods, including the time series analysis or the forecast analysis and the survival analysis, which could be reported in the form of hazard ratio. So, however, few of these researchers recognize that every epidemic has also a geographic component, Disease has a person component, a time component, and a place component in the definition of the classical epidemiology. But little emphasis has been given for the component of the disease with regard to the geographic location or the place. While more emphasis has been given for example, by the time component, as indicated by more time series analysis and survival analysis methods, but little emphasis has been given for the place component of the disease, that is the geographical component of the disease. So the logic of using geography to study disease or healthcare is derived from appreciation of factors causing non-uniformity of disease distribution. The logic or the reason of just using this geographic information to the spatial data analysis originates from appreciation of the factors causing the disease non-uniformly from place to place, A single factor X, like for example, let me say, a single factor X, I think, what's going on? A single factor X, for example, let me say temperature. And now the health condition is, let me say now, malaria. Or the prevalence of malaria, it means. The prevalence or the number of cases or the prevalence of malaria. And the factor is, for this demonstration, temperature. Could we expect, okay, now let's see the prevalence of malaria in different geographical locations. The prevalence of malaria in maybe Devra Brahan, which is a coldest area in Ethiopia, maybe. In Devra Brahan, the prevalence of malaria may be in, I don't know, in Humara and Matama. The prevalence of malaria may be in Addis Ababa. What did you expect? The prevalence of malaria in Humara, that means in the hot areas, in the high temperature areas, the prevalence of malaria will be high. In the cold areas, the prevalence of malaria is low. So that means temperature, a single factor, have contributed for the prevalence of malaria to vary from place to place, you know. So that means temperature have different effect on the prevalence of malaria across different geographical location. So that if you calculate or estimate the beta coefficient of temperature on the prevalence of malaria at Devre Birhan, it might be, for example, negative 0.04 or something like that. And again, the beta coefficient of this the same variable temperature, maybe at the hot areas like Humara and Matama, it might be positive 0.6. And the same variable again for temperature, the beta coefficient for temperature at Addis Ababa, it might be maybe 0.04 or 0.02 or whatever. You see, the same factor or risk factor have different non-uniform effect among different geographical location. So the same factor or predictor variable or independent variable is having different beta coefficient. You see, in Devre Birhan, negative 0.04, in Homara and Matama it is 0.6, in Addis Ababa it is 0.02. A single predictor variable or factor is having more than one beta coefficient. This is said to be in spatial epidemiology, it is said to be the geographically weighted regression, you know. We'll see that by its own section. So the geographical weighted regression is dealing about calculation of the effect of a single predictor variable across different geographical areas. So that is why the spatial epidemiology is originated. Because different risk factors are affecting the disease distribution non-uniformly. So the beta coefficient cannot be uniform for a single factor. It is non-uniform. So the beta coefficient will vary from place to place for a specific predictor factor, you know. That is why spatial epidemiology has been originated, you know. So the logic of using geography to use or to study disease or healthcare is derived from the appreciation of factors causing non-uniformity of disease contribution. That is the reason for the origin of spatial epidemiology. So these factors might be physical factor, environmental factors, social factor, economic, cultural factors, and genetic factors, you know. As I have said before, all these factors will not be the same in every corner of geographical locations. So the physical factors, the environmental factors, the social, economic, cultural, and genetic factors will be different in different geographical location. So the variation of these different factors in different geographical location will make the disease to vary from place to place, you know. So that the effect of these predictor variables or factors from geographical location to another geographical location will vary. It will not be uniform, you know. It will not be uniform. So, for example, disease may be associated with environmental pollution, you know, linked to individual or group behaviors, or associated with genetic predisposition. You see, if you want to associate or link a certain disease condition with environmental pollution might be in some part of the world, but environmental pollution may not be there in other parts of the world, you know. So that the variation of this environmental pollution from geographical location to geographical location will make the disease to vary from place to place. So the effect of environmental pollution in one area will not be the same in another area. So environmental pollution will have different effect or beta coefficients for the occurrence of that specific disease among different geographical location. Similar with other factors, individual or group behaviors and genetic predispositions will have different effect among the community in different geographical area. So, in turn, conversely, all these factors may have spatial distributions influencing the extent and intensity of a particular disease, you know. So, these factors may have a spatial distribution. That means the spatial distribution of these factors could vary from place to place. The genetic factors, the behavior factors will vary from place to place. So they do have a spatial distribution, different spatial or geographical distribution. So if the factors are spatially or geographically distributed in a different pattern or way, so the different distribution of these factors in different geographical location will make the occurrence of the disease to vary from those geographical locations, you know. So that is the idea or the objective and the concern of spatial epidemiology and the definition of spatial epidemiology. So this is the idea of spatial epidemiology, and by now you should understood that spatial epidemiology is concerned with the distribution, the knowing or investigating the distribution of geographical variation of diseases and in relation to different factors. So the variation of the disease in line with or according to the geographical location will be studied, and again the factors will be investigated, you know, in spatial epidemiology, and which is very different from what you have learned before, still now. It is attached to the location where the event is occurring, the place where the event is occurring. And why you are interested to the place where the event is occurring? Because risk factors are distributed non-uniformly in different geographical locations. And then the non-uniform distribution of risk factors in different geographical location makes the disease to distributed non-uniformly. And a single predictor factor or risk factor finally will have a different beta coefficient or estimate of influence or amount of effect in different geographical locations. So one specific variable, if you collect a data in 10 geographical locations, a single predictor variable will have 10 beta coefficients, whether they are statistically significant or not. That specific single factor will have 10 beta coefficients. So each predictor variable will have a beta coefficient of the number of geographical locations included in the study, whether they are statistically significant or not. Why? Because these risk factors are distributed non-uniformly in different geographical locations. So the non-uniform distribution of these risk factors in different geographical locations makes them to have a non-uniform effect on the outcome variable in those geographical locations. That is why the single predictor variable will have different beta coefficients in different geographical locations. And that is said to be the geographically weighted regression method in spatial epidemiology. So this is a very special and the most interesting aspect of spatial epidemiology, you know. So by now, I'm sure you have understood what does this spatial epidemiology mean and the concern or the objective of this spatial epidemiology. Okay, so now let's see the types of spatial epidemiology inquiry, or maybe the components of spatial epidemiology. The first one is disease mapping. The first thing, knowing the place where the disease occurs. That is disease mapping. And after knowing the place where the disease occurs, or after disease mapping, the next thing is knowing whether there is an relation or association between the risk factor with the disease in that geographic location. So to know that association or a relation, we need to do a geographical correlation study, you know? Geographical correlation study. You remember ecological study designs, which uses a population level or aggregated level data in a specific geographical location. And then correlation coefficient will be calculated. Ecological or correlational studies has been named because of this, because a population level or aggregated data at a specific geographical location will be taken, and the population level aggregated risk factor with that of the population level disease status will be correlated, But in the case of this spatial epidemiology, what will be spatial in addition to that ecological study design is, there is always a geographically referenced data, a spatial data. That means the place where the risk factor is measured and the place where the event has happened should be described or measured in terms of its geographical location by measuring the longitudinal and the latitudinal location of the data, to know the place where the event and the risk factor occurs. So by having this correlation, we can know whether there's an association or relation between the factor, that is the risk factor, and the disease. And the third component is risk assessment in relation to point or line sources. A risk assessment, actually, line source and point source. Point source is specific to a certain geographical location, but line source is just across some delineated geographical area. It covers beyond a specific geographical location. A line source, which occurs, an event occurring some geographical location, and it includes neighboring areas in the border line of that geographical location, will be just included, But the point source is event occurs only at the point area, not at a specific geographical location. But line source covers more larger surface area or geographical area than the point source, So we need to assess this risk, we need to do this risk assessment whether the source is the point source or the line source. Is it at a specific geographical location, or does it include the neighboring areas in which where the disease occurs, And the fourth is cluster detection and disease clustering. We need to do a cluster analysis, whether there is clustering of cases or not. If there is clustering of cases, where the clusters did occur, the place, the geographical location where the clusters occur will be detected, So these are the components or the types of spatial epidemiological inquiry. Okay, so disease mapping is the first component or the type of epidemiological inquiry. So in disease mapping, we are trying to establish a visual summary of complex geographic information. The visual summary of where the event occurs will be mapped. So identify subtle patterns. Subtle. The word subtle is very important. We are not just specific to where the disease occurs. This is a visual pattern or visualization simply. It is not to the level of objective measurement, It is not to the level of objective measurement. Rather, it is a subtle identification of subtle patterns in the data that are not given importance in tabular or other forms of presentation. You see, these patterns were not given emphasis in terms of tabular or other forms of presentation. So there is a subtle pattern in a specific geographic location. So in order to indicate that, the disease mapping will be very important. And it is used mainly for descriptive purpose only, The descriptive part of the spatial epidemiology is, the place where the disease occurs. So this descriptive pattern again will enable us to generate a hypothesis regarding the etiology. We can generate a hypothesis. Why the disease occurs at a specific geographical location? Okay, might be because of this, and these factors. We can generate a hypothesis. And plus it can be used, this especially disease mapping is very common and used for surveillance to highlight those areas which are apparently at high risk, Disease mapping. At the end of disease mapping, we are going to do a cluster analysis, hotspot analysis, and then we'll identify the place where at high risk. So this is very important. In order to identify the event where it occurs, in order to generate a hypothesis with regard to the etiology for the occurrence of that specific disease in that specific geographical location, and for surveillance purpose, and to identify those areas which are at high risk of that specific condition. And plus to aid or to support policy formation and resource allocation, Finally, the purpose of knowing the place where the disease occurs and the purpose of knowing which areas are at high risk is in order to just inform for policy formulation and for even a resource allocation for intervention, At the end of the day, the final goal of just any investigation is for intervention. So for intervention, there should be also a resource, So in order to allocate which resources should be allocated to which geographical areas, we need to know the disease where it occurs. And we need to know the geographical locations with high risk by using the disease mapping, So it is also useful in placing specific disease clusters. It is also useful in placing specific disease clusters. You see, in order to just know the place where the clusters occur, the aggregation of cases, the place where they occur, and results of point source studies in proper context. The source for that cluster, is it a point source or is it a line source? What is the source of that cluster of cases? To identify whether it is a point source or a line source, and to identify the place where the clusters occur, disease mapping is very important. So that is the objective or the idea or the intention or the goal of spatial epidemiology, And it is a basic tool in the analysis of public health data. Disease mapping is a basic tool. Without disease mapping, we cannot do further advanced analysis, Further advanced spatial analysis could be done as far as we do have a disease mapping data, So this is a really very basic tool in the analysis of a public health data. Like, for example, look over this map, which indicates the number of cases of NTD, neglected tropical disease, with different color, And I'm sure you are common with such types of maps. But how these maps can be developed, How these maps can be developed. This map is developed by having the subjects with the condition, the number of cases with that condition, and the place where the subjects and the event occur. The place with its latitude and longitude geographic referencing system information. So in order to know the place where the event occurs or the subjects where they lived, we need to have a geographic referencing system or information, That is simply we need to just measure the latitude and the longitudinal location of the subjects where the data was collected. So by knowing the number of cases, and by having the spatial location or the geographical location where the subjects live, we can just map this disease. And by having this disease mapping, we can know where clustering of cases are there. The place where. Like for example, look over here, this red line box, greater than or equal to 5 entities present. Where? In these geographical locations. Yeah? You can name the countries or maybe the continent. You see? So where are clusters of cases happening? Okay, including in our country, Ethiopia, and in Egypt, most of the African countries, and maybe in the Southern America here, around Brazil or maybe Argentina, whatever. So by having a look at on the disease mapping, we can know the place where disease clusters occur. 4 entities present with this color, with these different colors, can tell us the number of cases and the place where each are occurring. So disease mapping is very fundamental. To know the place where the disease occurs and to know the clustering of cases, the geographical location where the cluster, okay, and to know the places which are at risk. And another additional disease mapping is here again. This map tells the types of the diseases that is occurring maybe all over the world, but most of African countries are included here. So the type of the disease that is occurring, the heart disease, cancer, HIV, tuberculosis, respiratory infections, whatever. So which type of disease is mostly occurring and in which geographical areas? You see, for example, tuberculosis is common in most of African countries, including our country, Ethiopia, Somalia, and maybe here around. You can have a look at over here. So which types of diseases are very common in which type of geographical location? So in order to identify such types of disease clustering and the place where the types of diseases are more common, we need to do a disease mapping. That disease mapping is very fundamental. But to map this, to develop this disease mapping, we need to have the number of cases of that health condition and the place where the cases are living, the geographical location, which is measured by the latitude and the longitudinal measurements. Otherwise, if it is not attached to the geographical measurement, then that data cannot be attached with the geographical locations. That is very difficult. So the second type of spatial epidemiology inquiry is the geographic correlation. The first one, we have seen that, mapping the disease. After mapping and after knowing the place where the diseases are located, we need to know the relation between the risk factors with that of the disease, the cause and effect relationship at least. Okay, so that is possible by doing the geographic correlation. So we need to assess geographic variations across different population groups. We need to assess exposure to environmental factors. So like, for example, air pollution, water pollution, or maybe different chemicals in the soil. So we need to identify exposed and non-exposed groups to make a correlation among the exposed and among the non-exposed groups with the disease, without the disease, and by having the geographical location measurement. So socioeconomic and demographic measurements, like for example, like ethnicity of study participants, the income level, the educational status, whatever, the religion, the marital status, every number of things or factors could be considered. Lifestyle factors like smoking, alcohol drinking, chat chewing, any type of substance use, or even diet, nutrition. In relation to health outcomes, measured on a geographic scale, all these factors are measured at a large geographical scale, at an aggregate level. Otherwise, if it is individuals, that cannot be taken as a geographic scale, So all these risk factors will be measured at the geographic scale. Like, for example, the study of local lung cancer excess was associated with residence near or employment in arsenic industry. Being employed to this arsenic industry or living nearby this arsenic industry could be taken as those individuals are exposed. Those individuals who are not employed in the arsenic industry And those individuals who are living far apart from this arsenic industry will be taken as non-exposed. So these exposed, non-exposed groups will be also measured with respect to their geographical location. The latitude and the longitudinal measurements will be included, both the exposed and non-exposed groups. Then the exposure level at that geographical level will be aggregated. And then finally, the number of cases with lung cancer will be counted at the geographical location or totally in that specific area. Then after we'll make a correlation. So that is the second type of spatial epidemiological inquiry, which is said to be geographic correlation. The third type is disease clustering. Disease clusters and surveillance should be done. Disease clusters are spatial groupings of proximity, a spatial or geographical clustering or grouping of individuals which are living nearby the geographical areas are proximate to each other. So they will be grouped into one and counted as living in the same area. And characteristically related epidemics will be just investigated in terms of the cluster or not. So this implies an excess number of cases above some background rate, bounded in time and space. You see, clusters have been occurred if the number of cases are above or beyond the usual frequency of that specific disease in that specific geographical location at that point in time. If it is beyond the frequency of the usual frequency at that specific time and specific geographical location, then we say that clusters of cases are there. So clustering is just simply aggregating or grouping of individuals which are living in the proximate area with the same health condition. Number of cases with the same health condition living within neighboring or proximate geographical area are clusters. So this clustering has proved useful for health-related surveillance and monitoring. It is very common in health-related surveillance and monitoring, And proliferation of errors in disease mapping has led to inefficient decision making. If we made an error in disease mapping, then finally our conclusion and decision will be inefficient, because our conclusion and the result will be biased. If we are introducing an error or proliferated error in disease mapping, finally the result will be a biased one, and then the conclusion based on that biased result will be misconclusion. That misconclusion will lead us misintervention and misdecision making. That will be finally inefficient. The intervention will not be effective, because we are not acting on the right direction, on the right health condition, because of the misleading result that has been produced because of the errors during the disease mapping. The errors during disease mapping could occur in measuring the event itself and in measuring the geographical location where the event occurs. Okay, plus implementation of inappropriate health policies will be there if errors are there. Inappropriate health policies will be made, because of the error. Negative impact on advancement of scientific knowledge. A proliferated error during disease mapping can produce such types of negative outcomes, No advancement in scientific knowledge, inappropriate interventions or health policies, inefficient decision making will be there. So, like for example, have a look at over here, based on the geographical location, the geographical correlation, we can appreciate the values having a higher level of correlation and a lower level of correlation by just having a look at on the different colors and by having a look at the at where the geographical locations are specified, you know. So we can know in which geographical location this factor is more correlated with the disease status can be appreciated by having a look at on the geographic correlation. So clustering and surveillance are really very common in spatial epidemiology. The disease clustering involves an assessment of local or global accumulation of disease. Clustering could be made at the local level or at the global level. So clustering is simply accumulation of cases, aggregation of cases in a specific geographical location or maybe at the global level. When we are assessing the clusters of cases at the global level, we will refer the geographical place maybe at the continental levels or maybe at the country level. That refers to the global level, you know. But in the local level, it might be specific to a single continent or within a single country, specific to a single region or district or something more than or greater than that. So different types of clustering might be there. One, general or global clustering, as I have said. Analysis of overall clustering, tendency of disease incidence is done in the study region, maybe at the country or at the continent level. A specific or local clustering designed to examine exact locations of clusters maybe. And actually global or general clustering could be also made at the country level, you know. If the scope of the study is finally at the country level. But if it includes sub-units under that country level, if there are sub-units like maybe districts or zones or maybe villages, so that will be taken as a specific or local clustering, which is designed to examine exact location of cases or clusters in a specific geographical location, you know. So data for disease prevention and control purposes can be applied to problem of disease clusters through space, through time, through space-time pattern detection methods, either of the three methods. So data for disease prevention and control purpose can be applied to problem of disease clusters either through the place where the clustering occurs or through the time at which the clustering occurs, or maybe a combination of the two based on the time and the space at which the clustering occurs. So for the case of disease prevention and disease control purpose, this clustering could be made based on the space where the cluster occurs, or based on the time at which the clustering occurs, or based on the combination of the two. A spatio-temporal it will be. If it combines the two of the components, time and space, it will be a spatio-temporal analysis. It will be. The analysis includes both the geographical location where the event occurs and the time at which the event occurs. So the clustering could be made in terms of place or time, or in terms of space and time. So here it is just a disease map which could tell us or show us clustering of cases in different geographical locations. So by having these different colors, like for example, I think the green color is showing high clusters in these geographical areas, around here and maybe here. And it is very common in these areas, especially. And then the next clusters are represented with this color. Just by having these different colors, we can have a look at where different clusters are happening, and even when, by the time. The combination of that, we know. The time is also referenced over here in 1970 and in 1990. You see, the clustering was more common during the 1970 and around maybe the name of the country is given here around and even here. You see, in terms of geographical location and in terms of time, it is a combination of the two. But in 1990, it is becoming more or less clustered, compared to the 1970. And even in terms of the geographical location, it is more specific to just narrower areas. In 1970, it covers a wider areas. In 1990, it only covers small areas, the higher clusters of cases are becoming less and less in terms of the geographic location. And even in terms of the time, it has reduced too much from 1970 to 1990. So this is just appreciation of the disease clustering in terms of time and place. Time and place. Here is another example, disease clustering only by place. It is only by place. Place A, B, and C, D, actually, here are labels A, label B, label C, label D. 4 places are given there. So, and the keynotes are here actually. That much it is not visible. So we can have a look at on the clustering of the disease in terms of the geographical location, where it happens mostly, where are the clusters placed can be appreciated by having a look at on the disease map, So now, as we have said before, spatial epidemiology is the description and analysis of geographically indexed health data with respect to the demographic, environmental, behavioral, socioeconomic, genetic, and infectious risk factors. So it is a dynamic body of theory and analytic methods concerned with the study of spatial patterns of disease, incidence, and mortality. A dynamic body of theory will be there. Why? Because there are different risk factors which have been listed over here, whether demographic, environmental, behavioral, socioeconomic, genetic, or different risk factors will be considered in order to just predict whether there's a relation between these risk factors with that of the disease variation in the geographical location. So we will develop a dynamic body of theory which could tell us the possible or show us the possible relation of these risk factors with the variation of the disease in the geographical location. So that to prove or disprove these models and theories, finally analytic methods or analytical analysis or analytic regression methods will be made, which is concerned with the study of spatial patterns of disease, incidence, and mortality. You see, in order to investigate this body of theory and analytical methods will be made in order to investigate the spatial patterns of disease in terms of the incidence of the disease or the mortality or the morbidity, whatever. So that is generally the concern of spatial epidemiology. The spatial epidemiology is a branch of epidemiology that explores the spatial distribution of diseases and their determinants. And it involves the study of geographic distribution, patterns, and determinants of health and illness within a population, So the aim of spatial epidemiology is to identify the factors that influence, the aim of this spatial epidemiology is to identify the factors that influence the geographical patterns of disease and to develop strategies to control them. That is the overall goal of spatial epidemiology. To identify the factors which could influence the geographical patterns of disease. And after identification of these factors, in order to control them. That is a general objective and perspective of spatial epidemiology. So spatial epidemiology is now particularly important in public health because it allows us to identify the clusters of disease and outbreaks and to identify environmental and social factors or determinants of health that contribute to the occurrence and the spread of disease among geographical locations. So by mapping the distribution of a disease, we can identify the high-risk areas and we can focus public health interventions where the most population is affected, By having a look at all the disease mapping, we can identify the high-risk areas and we need to give a priority for those high-risk areas to take an intervention. So moreover, it can help to identify the individual level and environmental level factors that contribute to the development of the disease. You see, in spatial epidemiology, it is possible to investigate both the individual level and the environmental or the geographical level factors that contributes for the existence of the disease. So spatial epidemiology relies on geographic information system. Geographic information system. The geographical location data. Information is referring to data. So the geographic data where the event occurs should be collected, So spatial epidemiology relies on the geographic information system technology to create maps and interpret spatial data. So in order to create a map, we need to have a geographic information system data. And after creating that data, mapping, based on that map, we can interpret, the spatial data. Or the spatial data is to mean the geographical data. So this geographic information system, GIS technology, allows researchers to visualize, to look into and explore the spatial or the geographical patterns and to identify high-risk areas and conduct spatial analysis to investigate the relationship between place and health, So geographic information system is very fundamental. In order to visualize or look into the spatial pattern or the geographical distribution of a disease, to identify high-risk areas, and to conduct the spatial data analysis. Why? To investigate the relationship between risk factors which are attached with the geographical location, the place, with the health of the community. So this geographic information system is really very important for spatial data or spatial epidemiology. So spatial epidemiology is an important tool for public health international that allows us to identify the patterns of diseases and their determinants. Because by understanding the geographic distribution of disease, we can develop effective public health intervention that mitigates their impact, the impact of these risk factors, and to improve the health of the population, So that is a general idea and intention of spatial epidemiology. So, is there any relation between health and geography, that is medical geography? This health or medical, by the way, this spatial epidemiology has been also called as a medical geography. In different textbooks, you could get either spatial epidemiology or medical geography. So, this spatial epidemiology or medical geography is one sub-discipline of human geography, One sub-discipline of human geography, which provide a spatial understanding of or a geographical understanding of a population's health, distribution of disease in an area, and the environment's effect on the health and the disease, which is very fundamental. So, this medical geography or spatial epidemiology seeks to explore the social, the cultural, and the political context for health within a framework of a spatial organization, within a framework of geographical location or geographical organization. So, deals with this spatial epidemiology or in other terms, medical geography deals with accessibility to healthcare. Is healthcare facilities, are they accessible for the population? Accessibility, by the way, is referring to the geographical distance of the health facilities to the households where the population is living. Are the healthcare facilities accessible to the community? Are they nearby to the community? In order to measure this accessibility or distance of or near whether the healthcare facilities are nearby to the community or far apart from the community, we need to measure the geographical location, where the facilities are located and where the community is living. And spatial distribution of healthcare providers, the professionals, where they are living. And the disease distribution in terms of the geography. So it is concerned with monitoring how relevant demand is there in the community and how supply and service levels vary across geographical units, Is healthcare accessibility the same, or does it vary from geographical location to another geographical, from region to region, from district to district? In order to measure whether healthcare facilities or healthcare service is accessible for the community, in order to measure this accessibility, medical geography or spatial epidemiology is very fundamental. So, it identifies inequalities in the health facility or funds distribution and or allocation of resources, By studying the accessibility of healthcare for the community, we can measure the inequality in terms of the healthcare facility in the community and even the resource distribution. Really, is it accessible equally? Is there any fair distribution of resources and healthcare delivery for the community? In order to just measure and judge this medical geography or spatial epidemiology is very fundamental. So spatial analysis of population-based measures of cases, population-based measures of access to healthcare delivery, and resource allocation is a concern of this spatial epidemiology. So examples of these types of studies include studies of physician supply and demand by region or area. You see, we are attaching to the area or the geography. Patients' origin and geographic access studies can be done. Geographic variation in medical outcomes and practice patterns. Analyze geographic variation in patient flows. It can be done, So that is a concern of spatial epidemiology. So here is an example of a certain health index. Based on this color and the keynote, we can just appreciate the place where the healthcare accessibility index is more high and low in different geographical locations, So healthcare accessibility could be just measured and evaluated by this spatial epidemiology or medical geography. So geographic access, when we say geographic access is defined as the absence of barriers. If it is accessible for the community, there should be no barrier in between the healthcare and that of the community. Absence of barriers, including the distance, the transportation, and other physical challenges in accessing the care when it is needed. And this is influenced in part by decisions made in the allocation of the resource, by the way. Any healthcare facility requires its own resource, But in order to just distribute a certain resource, it makes or it demands decision making. It is again influenced by equity and investment into the infrastructures. So geographic accessibility of healthcare facilities will be judged according to this or by medical geography or maybe spatial epidemiology. So this geographical epidemiology or maybe spatial epidemiology is a description of spatial patterns of disease, morbidity, and mortality. Formulating hypotheses about the etiology of the disease with that specific geographical location. a reflection of different needs of public health specialists and epidemiologists in assessment of ill health etiology. Methods of geographical epidemiology are, as I have said, disease mapping, disease clustering, ecological analysis. And multi-level analysis or multi-level modeling could be made, beyond ecological analysis and ecological correlation. Geographical weighted regression, Bayesian regression, multi-level regression, spatio-temporal regression could be made for spatial epidemiology, So multi-level modeling can be made because, as I have said before, in spatial epidemiology, it is possible to include both the individual level and the environmental level factors. So that means we do have lower level variables and higher level variables. So it is possible to do a multi-level analysis in spatial epidemiology or in spatial data analysis. Not only multi-level, it is also possible to include a Bayesian multi-level spatial data analysis. So this multi-level modeling used to determine how much of ecological effect, that is the effect at the larger geographical unit, can be explained by variations in the distribution of individual level risk factors and integrated into geographical epidemiology, So that is really very important. So the relation of this spatial epidemiology and that of infectious disease is again another concern. Explaining spatial patterns of infectious disease. Explaining spatial patterns of infectious disease. The socio-demographic and epidemiological data sets. Understanding and predicting spatio-temporal transmission of dynamics could be explained, And predicting impact of control interventions that are driven by geographical factors. After identification of these geographical factors for the infectious disease, an intervention could be applied there. So in order to predict the impact of that intervention for that specific geographical location, this spatial epidemiology could be applicable or useful, To design or evaluate optimal resource allocation, as it has been said before, generating cost-effectiveness analysis that incorporates spatial component, knowing that this is geographical location will make us to be cost-effective, because by knowing the place where the disease occurs, we can appropriately allocate the resource and take an intervention, and we will be cost-effective for that. But if we know the geographical location, you will try in geographical location A one time, and then you will fail. And then you will try another time in geographical location B. So that will just waste your time and your resource, So quantitative approaches that rely on mathematical models could be also applied in spatial epidemiology, for especially infectious disease epidemiology. So why is this geography is important for public health policy? That means geography refers to the geographical location or the spatial data. Why it is important for public health policy, Informed decision making leads to development of effective public health policy based on understand the disease risk factors and how risk factors such as genetic, lifestyle, or environmental and occupation interact with the social built and the natural environments. You see, why this geographical location or study of the geographical pattern of a disease is important for public health is because informed decision making leads what? It leads us the development of an effective public health policy. That effective public health policy will make us to be effective in the intervention of the disease. So to develop this effective public health policy, we need to have an evidence on the disease risk factors and how they interact with each other, and finally to the geographical and the environmental factors. So knowing the factors and their relation with the geographically attached event or disease outcome, that will enable us to develop an effective public health policy or intervention. So understanding geography, including the arrangement of health services and the location of these health services, and nature of environmental exposure is crucial in assessing interrelations inherent in many health-related risk exposures. Knowing the interrelatedness between different risk factors, including the geographical location with the disease status, is very fundamental for us to develop an effective public health intervention. So many core geographic research themes are health inequalities and polarization. Scale, globalization, urbanization are directly related to public health. Because this globalization, urbanization are directly related to the health of the public or the community. So knowing the geography or the place where the people are living is very fundamental. Because secondary to urbanization, because of secondary to urban globalization, there will be aggravating risk factors for the health of the community. So where does urbanization occurs? The place where more urbanization is taking place, and knowing the place where more globalization is taking place is very fundamental to take an effective public health intervention. So here are examples of health geography research relevant to the public health policy. You can have time to read these examples. So how do we assess the physical access to health services? That is one of the components of the spatial or medical geography. So physical access to health service differs based on one's geographic location within a country. So the accessibility of health facilities will be dependent on the place where the individual or the community is living. So the place where, for example, let's have a look at on this. The dots at the center are just the facilities. Here are the facilities, and here are the facilities. There are some individuals who are far away from, or households, those facilities, and there are some other households which are near to the health facilities. So we need to measure the distance or the health facility accessibility to the community. In order to measure that, this spatial epidemiology is very fundamental. So location of healthcare facility depends largely on the nature of the healthcare system in operation. And again, it is influenced by historical factors due to heavy investment costs in facilities such as hospitals and surgeries. We could or we would expect the distribution of facilities to be fairly closely matched distributed to the demand. Market-oriented system might mirror locational patterns that we find in other business sectors such as retail location. Well-established patterns of utilization increasing with access, that is, people who have easier access to healthcare use it more often than people who do not have access to the healthcare. So we need to just measure. So this health service accessibility will be measured and studied by the spatial epidemiology. The spatial scale, globalization, and urbanization are the issues or the concerns for, again, this spatial epidemiology. So these are crucial to health service provision and public health implementation. Global issues like environmental change, demographic transition, internationalization of health service organization. Now health service organizations are becoming internationalized. So because of environmental change, demographic change, internationalization of health services, all have geographic context. All these have the geographic context that directly influence the health policy. So that is why spatial epidemiology is very important for public health. So global patterns in infectious diseases, including HIV/AIDS, avian flu, COVID-19, Ebola, Zika virus, mumps pox. All this and others are really linked with the geography because of migration, because of population movement, and as a result, because disease diffusion. So knowing these issues is very fundamental for public health. That is why spatial epidemiology is very fundamental for public health intervention and for public health policy, you know. Another component is social and spatial inequalities in health. Social and spatial inequalities in health is concerned about the social component of the health dimension, the social and spatial polarization, especially with socioeconomic inequality, you know. The variation in socioeconomic inequality will have its influence on the geographic variation of the disease. So inequalities and poverty have prompted research that explores determinants and consequences of health variations because of these socioeconomic inequalities, including issues related to the poverty, healthcare access, public health. All these are influenced by the socioeconomic status of the community, you know. So identification of persistent inequalities in health between rich and poor community, and evidence that can support policies to address underlying causes of health problems is a concern of social and spatial epidemiology, you know. Okay, another issue why spatial epidemiology is important for public health policy is because spatial analysis is used for monitoring and evaluation. It is used for monitoring and evaluation, you know. Geospatial analysis enhances monitoring and evaluation. How? By adding a spatial dimension to the data. The spatial dimension, that means the location of the event to the data, that will help to understand where and how projects are being impacting the community. So knowing the place where the event is occurring will help us to understand where it is occurring and how the projects applied for that specific condition are impacting the community. Could be just monitored and evaluated, you know. So this integration allows for more informed decision making and can provide a richer understanding of project effectiveness. Because in order to just monitor and evaluate, if we know the place where it is occurring, knowing the place where it is being done can enable us to monitor that project, you know. Another issue is geospatial analysis. So the method of combining, examining, and mapping various types of geographical reference data, you know. This geographical geospatial analysis is a method of combining different geographically referenced data, examining those data, and finally mapping these various types of geographically referenced data. The word geographically referenced data refers to the location of the data is measured in terms of the latitude and longitude. So that is a concern of geospatial analysis, you know. And again, demographic, statistical, topographic, epidemiological, and other data will be analyzed. Okay, to turn this geographic data into information that can be used for program planning and decision making. You see, finally, this analysis will be used for program planning and decision making. And that program planning and decision making will be used for monitoring and evaluation, you know. Okay, the geographic information system techniques produce simple and useful maps. The geographic information system will produce a simple and useful maps, and these maps will be just used to identify the locations of health services or maybe the prevalence of a certain disease. And advanced geospatial analysis enables the examination of the relationship, the trend, the pattern, and the influences that may not be visible in maps generated from a single data source. So, you see, therefore, this advanced geospatial analysis will enable us to examine the relationship of different risk factors with the disease, to know the trend of that disease across the time or across the geographical location, and the influences that may not be visible in maps if generated from a single data source. A single data source may not be that much visible in a map, but if we aggregate the number of cases within a geographical location and if we map that, so that it will be used for such investigation, Again, this geospatial analysis will provide deeper insight about conditions and factors that influence health service and interventions. So by layering data from multiple sources and filtering and by applying statistical methods, it is possible to provide a deeper insight about the condition and the factors that are influencing the health service or the intervention across geographical locations could be appreciated by using this geographical or geospatial analysis, and that is really very fundamental for monitoring and evaluation. So, effective geospatial analysis for monitoring and evaluation depends on the availability of high-quality geographically referenced monitoring and evaluation data. The monitoring and evaluation data that is going to be collected should have a high-quality geographically referenced data, and again, it is dependent on the growing availability of spatially referenced country and region-level data on programs, populations in which the program is serving. And again, it is dependent on the context in which they operate. Make it increasingly feasible to use geographic tools to target interventions and more accurately, So here is generally the steps for geographical or geospatial data analysis in monitoring and evaluation. The first step in geospatial analysis for monitoring and evaluation is understand the project's context. The project which is going to be monitored and evaluated should be understood, that is the first step. Understanding the project's context. And next, develop a goal and evaluation questions. The second step is developing a goal. And the third step is define and explore the existing geolocated monitoring and evaluation data. We need to define and explore the monitoring and evaluation data, which is geographically located, And the fourth step is conducting exploratory data analysis. And after that, after exploratory data analysis, we need to ask this question. Will spatial analysis help to answer the evaluation question or not? If it does not help us, we will proceed to use the traditional statistical analysis methods. But if the spatial analysis method is useful to answer the evaluation questions, then we'll proceed to the next step for geospatial analysis of monitoring and evaluation. So the fifth step is identify and select the appropriate geospatial technique. The appropriate geospatial analysis technique should be selected, In order to select these geospatial analysis techniques, we need to ask these questions. Are we interested to know the global patterns? If we are interested to know the global patterns, we need to choose either of these geospatial analysis methods, the listed ones. Or are we interested to know the locational patterns? if we are interested to know these locational patterns, we need to use these location techniques. Or if we are interested to know predictive of spatial patterns, if we want to predict the spatial pattern, we need to know we need to use this spatial or geospatial analysis methods. So we need to ask these questions, and after identification of these questions, we need to proceed to the sixth step. Consider methodological issues, and next perform the geospatial analysis that have been chosen out of this. And finally, assess if the analysis answers the evaluation question, and present and interpret the results. That will be the geospatial analysis of monitoring and evaluation data, So that is why spatial epidemiology is very fundamental for public health policy, or for public health intervention, Okay. I think hereafter I need to stop here. The historical perspectives of spatial epidemiology will be dealt in the coming session,